Okay, so far guys, we have covered methods of factoring. We've talked about, if I can get this to work, there we go. We've talked about using the greatest common factor. That should always be the first thing on your mind. We talked about how do we factor x squared plus bx plus c. You have to find numbers that multiply to c and add to b. Then we talked about factoring, a little bit more complicated, ax squared plus bx plus c. Here you find numbers that multiply to ac and add to b, and then we have to use the factoring by grouping method. Okay, we're just going to talk about a couple of special cases here. Remember, a plus b squared is a squared plus 2ab plus b squared. So if I were to expand 2x plus 3 squared, that's 4x squared plus 12x plus 9. So the pattern here is you square that to get this number, you square this number to get this number, and then multiply. If you multiply the 2 and the 3 and you double it, that's how you get the 12, okay? So what I can do, I can recognize that pattern sometimes to quickly factor something. So when I look at this, that's a perfect square, that's a perfect square. So in this case, if this was going to be written as a plus b squared, well, the a is going to be 2, okay? The b is going to be 3, and then 2ab is going to be 12, okay? So this is 2x plus 3 times 2x plus 3, or 2x plus 3 squared. I had a teacher that called this a PST, perfect square trinomial. So anytime you recognize the first thing is squared, the second thing is squared, when you take the square roots, you get 2 and 3, double that, multiply 2 and 3, you get 6, double it, you get 12. If that's the middle term, you've got a perfect square trinomial. Now, I could do this without recognizing that. It just takes a little bit more time. 4x squared plus 12x plus 9. I need numbers that multiply to 36 and add to 12. Well, the numbers that multiply to 36 and add to 12 are 6 and 6. So this is 4x squared plus 6x plus 6x plus 9. Factor out of that, you can factor out a 2x, and you're left with 2x plus 3. Copy down the plus sign, factor out a 3. 2x plus 3. Your final answer here is 2x plus 3 times 2x plus 3, which is 2x plus 3 squared. Okay? So it just saves time if I can recognize the pattern. Okay? So to recognize a plus b quantity squared, you've got a perfect square on both ends. So that's a perfect square, that's a perfect square, and then double the product is the middle term. If it's with a minus sign, then that's going to be a minus b squared. So to check if this is a perfect square trinomial, the square root of that is 3. The square root of that is 5. If you double that, you get 30. Okay, so this is a perfect square. Okay, so this is 3x minus 5 squared. Okay. So again, all I'm checking is if the first term is a perfect square, the second term is a perfect square, take the square roots, double it, and if that is your middle term, if it's with a minus, then it's a minus perfect square trinomial. If it's plus, it's positive. So this one, the coefficient here, so that's a perfect square, and that's a perfect square. So if you take the square roots, 1 times 4, and you double that, you get 8. So this is a perfect square trinomial. So the square root of this is 1, the square root of this is 4, so this is just x minus 4 squared. Now the other way I could have done this one is numbers that multiply to 16 and add to negative 8. Well, that's negative 4 and negative 4. So this is just x minus 4, x minus 4. Okay. This one, I think we've worked this one, but 4x squared plus 9, that's a perfect square. So 2x. That's a perfect square, 3. If you double the 2 and this, 2 and 3 is 6, double it, you get 12. So this is just 2x plus 3 squared. Now the other thing I want to make sure we're solid, we've done factor by grouping, but there are times where you can see factor by grouping is not the intermediate step, like when we did the problems yesterday. It can be the method for factoring something. So if I look at this, there's no greatest common factor of all 4 terms. It's not one of my trinomials in quadratic. But if I look at this, and if I rewrite, so it's 2x cubed plus 3x squared minus 8x minus 12. Let's try to break it down into 2 different pieces. What can I factor out of the first 2 terms? Well, it looks like an x squared. And that's going to leave me with what? 2x plus 3. Okay. Copy down the minus sign. Now look at the 8 and the 12. What do they have in common? They have in common a 4, but technically it's a negative 4. What do you multiply negative 4 by to get negative 8x? That's 2x. What do you multiply negative 4 by to get negative 12? That's positive 3. So now I can factor out a 2x plus 3 times x squared minus 1. Now if I look at it, you're always asking with factoring, is there something else that can be factored? So if I look at this, x squared minus 1, those are perfect squares, right? How do I factor something that looks like a squared minus b squared? Remember, that's a plus b, a minus b. So this final factorization here is 2x plus 3, x plus 1, x minus 1. Okay. So that's the common thing that happens in all of our factoring is you learn different methods, but there are times where you have to use multiple methods to get to an answer. Okay. Let's look at the next one I'm seeing here. First step, is there a greatest common factor? With all 4 terms, there is not. So can I factor it by grouping? What do the first 2 have in common? That's 4x squared. And 4x squared to get 20x cubed is going to be 5x plus 1. Copy down the minus sign. The negative 45, the negative 9, they have in common a 9. Technically, it's a negative 9. What do you multiply negative 9 by to get negative 45x? That is 5x. And then plus 1. Now, if this is going to work, what I see in parentheses has to match. Otherwise, grouping will not work. So this is going to be 5x plus 1 times 4x squared minus 9. Now, can that be factored? Those are 2 perfect squares, right? So 4x squared minus 9, that can be factored. So this is 5x plus 1. And then this is what? 2x plus 3, 2x minus 3. This one, same thing. What do the first 2 have in common? It looks like they have an x cubed in common. And that leaves me with 3x minus 2 plus, and then I'm left with 3x minus 2. So this is 3x minus 2 times x cubed plus 1. Now the question becomes, can either of these be factored? This can factor again, but I'm going to leave it to your Algebra 2 teacher to teach you how to factor that one. It's a little bit more complicated, okay? So that would be good for this one. If I look here, what do these have in common? The first two have an x squared in common, and that leaves me with 2x plus 5 minus, I'm factoring out a negative 1, so 2x plus 5, so this is 2x plus 5 times x squared minus 1. That's the difference of two perfect squares again. So this is 2x plus 5, x plus 1, x minus 1. Similarly here, the first two have in common an x to the fourth, and then that leaves me with what? X squared minus 1 minus x squared minus 1. So this is x to the fourth minus 1 times x squared minus 1. Now this one gets a little complicated. Just always ask yourself, can I factor further? Well, x squared minus 1, that's x plus 1, x minus 1. Okay. Now, what about this? Are those perfect squares? Answer is yes, those are perfect squares. So that's x squared minus 1, x squared plus 1. Then, can I factor any further? Yes, that is a perfect difference of squares right there. So this is going to be x squared plus 1. So this is going to be, this term right here is x plus 1, x minus 1. So I'm going to be left with x plus 1 squared, x minus 1 squared. So that's completely factored for this guy. Okay. And that should lead you up into homework for this particular section. Okay.